The question is that a furnace has wall of temperature 1600 degrees centigrade. What is the wavelength of maximum intensity emitted when small door is open? So we will find the wavelength, maximum wavelength, as we know that from Wien's displacement law. The solution is that from Wien displacement law. Displacement law that lambda maximum is equal to B divided by K or small b divided by T. This is equation 1. Where B is the Wien displacement constant. B is Wien's constant. And the value of this B is 2.89 into 10 raised to the power minus 3. And T is the temperature. Where temperature is in Kelvin. Now first of all, we convert temperature into Kelvin from degree centigrade. The T is 1600 plus 273. This will become 1873 Kelvin. This is the temperature. This is the value of B. Put these value in equation 1. So we have equation 1 become equal to lambda maximum and 2.89 into 10 raised to the power minus 3 divided by 1873. Calculate this. This is become equal to 1.542 into 10 raised to the power minus 6. Lambda. So this is we write in meter, or we know that the prefix 10 to the power minus 6 is equal to micro. So convert it to micrometer. The lambda maximum will be equal to 1.542 micrometer. This is the required answer.